Alright, this is part 2 of our going over the final exam review guide, and we're starting on the third page here, question number 14, and the first question asks us to find the y-intercept of the function y equals negative 2 times 8 to the x power. Now, I guess the first thing here is just making sure we understand what the y-intercept is. What we're talking about is where this graph, which is exponential growth by the way, crosses the y-axis. Well, wherever it crosses the y-axis, I don't know where, but I know it's 0 something, right? The x-coordinate 0. And so the easiest way to find the y-intercept, of course you can always plug it into your graphing calculator and look at the graph, but all I really have to do is input a 0 for x. And anything to the 0 power, that's a 0 right there, is 1. So y is simply negative 2, and the y-intercept is 0, negative 2. Number 15 is an exponential growth problem, specifically dealing with interest, and it gives us the equation here, so that's not one that it looks like we have to have memorized, though not a bad idea to have it on your note card. You'll notice this formula looks a little sparse for compound interest, and that's because the interest is only compounded once per year. So we've got a person investing $450. That is our principal, $450. And we're going to do 1 plus the interest rate. Now remember, the interest rate's as a decimal, so 8% is actually 0.08. And then we're going to raise that to the n, or the way you've seen it, we raise it to the t power. And the time factor here, as it states in the problem, is 5 years. So it's really just a matter of evaluating this on my calculator. Just keep in mind that you want to have those parentheses there, but you should be able to type it in just as it is. 1 plus 0.08 to the 5. And if I did not type that right, so just one moment. There we go. And I should end up with approximately $661. And looks like 20 cents there if I round. Okay. Number 16 is going to be very, very similar. Again, it gives us an exponential growth model with the value of a company. And the biggest difference here is how we read the time factor. So here's the model. There's the exponential growth model. The model starts in 97, and I want to know what the company would be worth in 2001. Well, the key thing is I have to know what to input. I have to input the number of years since 1997. Well, 2001 minus 1997 is 4 years that have passed. So I am trying to evaluate y equals 350, 1.05 to the 4. And again, if I put that in on my calculator, 350, 1.05 to the 4th power, the company is worth approximately $425.43, and that's in the millions of dollars, like such. Okay, number 17 asks us to graph the equation f of x, or remember that could be the same as y equals 1/5 to the x power. Now I think your best bet here is to enter this in the y equals menu on your graphing calculator, and I think I'll do that right now. Always keep those fractions in parentheses, 1/5 to the x power, and using my table, I can find that at negative 1, 1, 2, 3, 4, 5, whoops, negative 1, 5 here is a point on this graph, and 0, 1 is a point on this graph, and 1 and 0.2. This one's kind of tough to sketch, but it's exponential decay that dives very quickly, and you can pretend that that line goes through those 2 points. But that's what the graph should look like. You could even just hit the graph button on your calculator and match to the multiple choice answers. Okay, moving along here, we've got a simplify problem with some exponents, and we'll be using some exponent rules for this. And my advice with a problem like this is to start a piece at a time. We can do some simplification, but only with what we know. See, I can simplify numbers with numbers. 5 over 45, I should be able to cancel a 5 and get 1 over 9. Of course, I won't need to leave that 1 in my final answer, but it's just there for clarity. And then the m's also cancel. But I can only cancel or simplify m's with m's. Now you can think of this a couple of ways. I can either think of it as 5 of the m's canceling with 5 on the top. Or remember, I can subtract the exponents. M to the 17 minus 5 is m to the 12th, no matter how you look at it. So I'll get 1m to the 12th over 9, which you can just write as m to the 12th over 9. Okay, number 19, $4,000 invested at 12% compounded continuously. Find the balance after 6 years. Well, again, we have the interest formula here. That's kind of handy. I want to know how much money I'll have. My principal, P, is $4,000. That's what I started with. Remember that E is a special number like pi, and you have an E button on your calculator, so we'll just leave that as it is. And then up in the exponent, it's going to be the rate, and again, 12%, but as a decimal is 0.12. And then times time, problem asks for 6 years. Now, when you enter this into your calculator, keep in mind, a lot of times when I do powers, I want the whole power in parentheses, and when you type it in, it actually gives you a power, or a set of parentheses, excuse me. So 4,000 e to the 0.12 times 6, close my parenthesis, and I will get approximately $8,217.73. If you feel like you have that equation but you're not getting the right answer, you're probably typing something incorrectly in your graphing calculator, so that's a great thing to ask a question about. All right, moving along, number 20, we're getting into the next chapter here, talking about logarithms, and we want the log base 4 of 4,096. Now, remember what the log is asking for. What this is asking is 4 to what power, 4 is the base, gives me 4096. Now, since you have multiple choice, you can probably just do some guessing and checking on this. 4 to what power gets me that, or you can use the change of base formula. The change of base formula says that I can take the log of 4096 divided by the log of 4, the base. And keep in mind that this is, if I don't write a base here, it's base 10, and we do have that button on our calculator. Either way you do it, I'm going to use the change of base formula here. Log of 4096 divided by log of 4, I'm going to get 6, because 4 to the 6th power is 4096. Right now, 21, we are going to use a formula that already has a log in it. This one happens to be for Richter scale measurements. I think we may have done some problems based on this when we were in that chapter. And here's the model right here. And R is the Richter scale rating, and I is the intensity of the earthquake. And so we want to find the Richter scale reading of an earthquake with 42 million as its intensity. So R equals log base 10, though I don't actually have to write the 10, of 42 million. And again, what I'm asking is 10 to what power here is 42 million. I've got the log base 10 button on my calculator, so there's no special stuff I have to do here. I can just hit log of 42 followed by 1, 2, 3, 4, 5, 6 zeros, and I end up with a 7.6 on the Richter scale. Okay, moving along. Number 22 asks us to express this following thing as a single logarithm. Another way that this you may remember this is this would have been the directions condense. Now, there's one property of a logarithm that deals with addition. It says if I have the log of A plus the log of B, that can be expressed as log of A times B. So what I can do is simply condense this to log base 6 and then look at what 12 times 30 is. And it gives me 360. Okay, just a direct application of one of the properties of logs that says I can either expand a multiply to an add, or I can condense an add to a multiply, but that's the relationship we looked at. Okay, 23 is an equation to solve. 5.73 to the x power equals 21. Again, there might be some possible guess and check strategies here. It might be pretty quick to check the answer, but probably the most direct algebra way to solve this is to take the log of both sides. So in other words, take the log of 5.73 to the x equals the log of 21. And notice that the original equation is still there in blue, but I've just added a log to both sides. Now, one other property of logs that is helpful to me is that if I have the log of a power, I can bring it to the front. So what I really have is x log of 5.73 equals the log of 21. Now at this point I can get x by itself pretty darn quickly. All I have to do, see x is being multiplied by the log of 5.73, so to undo that I will divide by the log of 5.73 here and here. So of course these cancel, that was intentional, and x will just simply be whatever this guy is. So I'll just do that on my calculator, log of 21 divided by log of 5.73, and I should end up with x being approximately 1.74.